Now, we all know that fractions are one of the most feared concepts in the study of mathematics. One of the greatest challenges is recognizing equivalent fractions, which can be determined by simplifying fractions. This video will provide a strategy for simplifying fractions. Our first stop in our fraction journey is determining when a fraction is actually simplified. If the numerator and denominator of a fraction are relatively prime, then the fraction is simplified. Simple as that. So this leads us to the definition of relatively prime. 1 is the only common factor between the numerator and denominator of a fraction. There are many strategies that can be implemented to develop a firm understanding of simplifying fractions. One of my favorite strategies to introduce is applying the rules of divisibility to the numerator and denominator to find a common factor. Let's start with the rule of divisibility for 2. If the digit in the ones place is even 0, 2, 4, 6, or 8, then the entire number is divisible by 2. Looking at 458, 8, which is even, is in the ones place, so the entire number is divisible by 2. Dividing 458 by 2, we get 229. Let's see if this works for an entire fraction. We will look at the fraction 6 over 28. The numerator is a single digit, even number, which is divisible by 2. The number in the denominator has an even number, 8, in the ones place. Both of these numbers are divisible by 2, so dividing 2 into both numbers allows us to simplify this fraction to 3 over 14. Now that we know the rule of divisibility for 2, let's move to the rule of divisibility for 3. A number is divisible by 3 if the sum of all of the digits is divisible by 3. For example, let's look at 528. If we add up the digits, we get 5 plus 2 plus 8, which gives us 15. 15 is divisible by 3. We actually could go one step further and add those digits until we get a single digit. 1 plus 5 would give us 6, which is still divisible by 3. Dividing 528 by 3, we get 176. Let's apply this concept to a fraction. We have 15 over 117. In the numerator, we have 15, which breaks down to 1 plus 5 equal to 6, which is divisible by 3. In the denominator, we have 117, which breaks down to 1 plus 7, which is 9. Since both the numerator and denominator are divisible by 3, we can divide 3 into both the numerator and denominator to simplify this fraction, getting 5 over 39. The last rule of divisibility that will be covered in this short tutorial is 4. If a number is divisible by 4, then the last two digits of a number are divisible by 4, which means the entire number is divisible by 4. In this case, since 36 is a multiple of 4, then 4 will divide 536 evenly to get 134. Let's apply the rule of divisibility by 4 to a fraction. In the numerator, since the number is a two-digit number, the entire number must be divisible by 4, which it is. In the denominator, the last two digits are 32, which is also divisible by 4. Therefore, both numerator and denominator are divisible by 4, which reduces the fraction to 5 over 33. This video explained the concept of using the rules of divisibility to simplify fractions. Given the brevity of the video, we did not have time to delve into some of the other popular rules of divisibility typically introduced with the concept of simplifying fractions. Here's a list of some other rules that can be helpful in simplifying fractions. When attempting to reduce a fraction, start by determining if the numerator and denominator are relatively prime. If they are not, attempt to apply each rule of divisibility until you choose one that works for both numbers. In some cases, you can apply one rule of divisibility and it will not be completely simplified. In that case, use the new fraction and work back through the list repeatedly until the numerator and denominator are relatively prime, which means the fraction is completely simplified.